Imagine looking up at the night sky and realizing that all the galaxies you see, and even those you can't, are racing away from each other, as if the universe itself is stretching apart faster and faster. That's the mystery at the heart of modern cosmology. Not only is our universe expanding, but it appears to be doing so at an ever-increasing rate. But why do scientists think the universe is speeding up? What evidence set us on this path? And what deep questions does this raise about the nature of space, time, and the ultimate fate of everything? Let's unravel the story, one that starts, as so many cosmic tales do, with light that has traveled billions of years to reach us. In the late 20th century, astronomers set out to make careful measurements of distant galaxies, using a special kind of exploding star called a Type Ia supernova as a cosmic ruler. These supernovae explode with nearly the same intrinsic brightness, meaning their apparent brightness tells us exactly how far away they are. By comparing their distances with how fast those galaxies are moving away from us, researchers expected to chart a straightforward history of cosmic expansion, like watching a firework fade as it rises. The farther away, the slower it seems to move. But when the light from these distant supernovae finally arrived, it told a different story. Galaxies weren't just flying apart. The farther away they were, the faster they seemed to be accelerating away from us. This was a shock. Until then, the expectation was that gravity would slow the expansion, maybe even pulling the cosmos back together across billions of years. Instead, the universe appeared to be picking up speed, as if there was some mysterious force driving the expansion ever faster. Let's pause and consider just how strange this finding is. If you throw a ball upward, gravity slows it down. Now imagine tossing a ball, and instead of it slowing, it suddenly accelerates away from you, ignoring gravity's rules entirely. That's what the universe appears to be doing, and it's utterly puzzling. Passage from the poet Rainer Maria Rilke's The Book of Hours. Let everything happen to you, beauty and terror. Just keep going, no feeling is final. Reflection. This line captures something essential about the universe itself. Its beauty, its terrifying scale, its unpredictable twists, and our drive to keep seeking answers in the face of deep cosmic mysteries. What then could be fueling this acceleration? Scientists gave it a name: dark energy. Not because we understand it. In fact, quite the opposite. Dark energy is a label for our profound ignorance. It's estimated to make up nearly 70% of everything in the cosmos, and yet we have no clear idea what it actually is. Some physicists compare dark energy to an energy inherent to space itself. As more space is created in the universe's expansion, more dark energy comes along for the ride, driving yet more expansion. A self-reinforcing cycle, making the universe's overall size increase faster the bigger it gets. Imagine a vast loaf of raisin bread rising in the oven. As it expands, the raisins, representing galaxies, move farther apart. But if you sped up the rising process as the bread stretched, you'd see an even more dramatic separation. This is what an accelerated universe looks like to astronomers. And yet, this entire notion rests on interpreting the faint flickers of distant supernovae. Are we sure they haven't changed over time themselves? Do we truly know their absolute brightnesses, when the conditions in early galaxies could have been wildly different from today? Here's where the story draws in other threads. When scientists measure the cosmic microwave background, the ancient leftover light of the Big Bang, they see signatures that match a universe that began extremely hot and dense and has been expanding ever since. The patterns in this background light give independent evidence for dark energy's effect, reinforcing the tale told by supernovae. But the plot thickens rather than resolves. A new cosmic controversy has emerged over the speed of this expansion, called the Hubble constant. When astronomers measure it using the local universe, supernovae, stars, and galaxies, they get a result. When they infer it from the earliest universe using the cosmic microwave background, they get a slightly different number. The two methods disagree. This Hubble tension has become one of the biggest mysteries in cosmology today. Why this disagreement? Are we missing some unknown ingredient in the universe's recipe? Could new physics be hiding just out of sight, warping our measurements of cosmic time and distance? Reflect for a moment with these words from the philosopher Heraclitus. No man ever steps in the same river twice, for it's not the same river, and he's not the same man. The universe, too, is forever changing. Every observation, every measurement is a new step into cosmic mystery. The more precisely we measure, the deeper the riddle seems to go. To truly test the idea of accelerated expansion, astronomers now employ multiple techniques. They map the large-scale structure of galaxies, tracing how groups and clusters have grown over billions of years. They measure tiny wiggles called baryon acoustic oscillations, faint echoes of sound waves from the early universe, frozen in the way galaxies are distributed today. They observe gravitational lensing, where massive clusters bend the light of more distant objects, magnifying and distorting their images. Even the way cosmic voids, empty regions, grow and stretch offers clues to how fast the universe is speeding up. With these methods, a remarkable picture emerges. The universe was indeed slowing down for its first several billion years, as gravity from matter tried to rein in the expansion. But at around 5 billion years ago, dark energy's repulsive influence overtook gravity's pull, and the universe's expansion began to accelerate. Think again of a car cresting a hill, slowing as it climbs, then speeding up as it descends. The universe had its own hill, and now we are racing down the other side. But what does this mean for the future? If the universe continues this accelerated expansion, distant galaxies will drift so far apart that their light will never reach us. Eventually, our night sky will darken as all but the closest galaxies slip over our cosmic horizon, invisible forever. Poetically, the universe's ultimate fate could be eternal isolation and darkness, a far cry from the fiery, crowded cosmos of its birth. The thought is breathtaking and a little unsettling. Carl Sagan once wrote, "We are a way for the universe to know itself." Even as galaxies vanish into the dark distance, our questions and curiosity burn as brightly as ever. Of course, nature sometimes surprises us. Perhaps dark energy is not a constant, but something that varies over time, growing stronger or weaker, leading to radically different endings for the universe. There are models where the cosmos tears itself apart in a final big rip. Others imagine a slower, gentler fade. For now, all we can do is watch the data, refine our techniques, and keep asking, why do we believe the universe is expanding faster than before? Because the very light from deep space, when decoded with care, indicates it. Because cross-checks from diverse cosmic measurements align with this strange picture. And because, all doubts and debates aside, the universe seems stranger and more marvelous than even our boldest theories can fully describe. Let's end with a verse from T.S. Eliot's 4 Quartets. We shall not cease from exploration, and the end of all our exploring will be to arrive where we started and know the place for the first time. The universe, it seems, always keeps something in reserve. Another puzzle, another moment of wonder. Our journey to understand why the cosmos is racing apart is far from finished. In the expanding darkness, you and I are part of that exploration, forever gazing outward, searching for meaning in the silent drift of galaxies. What will we discover, And how will it transform our sense of reality? That remains, tantalizingly, ahead. The universe isn't just expanding, it's inviting us to keep exploring, faster, farther, and deeper than ever before.